All right. So for today, what I need you guys to show me in order to be done with the lab is a simple plot of your data in Excel where you inserted your information that you have from the pH meter reading, and show me a curve like this where I see the dots. I also need to see the pKa for your unknown acid and your molar mass, and from those two things we're going to ID your unknown acid. So first I'm going to walk you through how to get the molar mass and the pKa and how we use this to identify our unknown acid. And then afterwards I'm going to show you how to make a titration curve, and you can do it in the lab or at home, the quick and dirty way, which is sufficient for the yellow pages, and then the more sophisticated analytical way, which I need to see for the formal report, which is due after the exams. You have a little bit of time. But for that, I need to walk you through a lot of steps how to do this. Okay, so let's start with the simple stuff, okay? The molar mass of my acid, okay, by definition is equal to the mass of my acid divided by the moles of my acid, right? Now, the question is, how do I get the mass and the moles of my acid given that I have this titration curve here, milliliters of NaOH added on the x-axis, and pH. So I have some sort of curve that looks something like this. Well, the mass is simple. How did we get the mass of the acid in this experiment? The mass? How did you guys get the mass of your unknown acid? You had this white powder? Yeah, you weigh it, right? Boom, and done. Weigh it. And let's say, for example, you have a number of about 0.1 grams, right? Something like this, right? That might have been different for different people with different acids, depending on how much volume you needed to equivalent. So we have the mass, but I need the moles of the unknown acid. So the moles of the unknown acid, we did exactly what you said, we titrated. So in order to get this, we titrate. Now, if I look at the curve, on this curve, how far did I titrate to? About 50 milliliters or something, right? So we titrated about 50 milliliters. Most people probably around 40. The question is, which data point from this curve can I use to calculate the moles of acid? Which specific point on this graph? Who said 3? You also said 3? What's 3? It's the technical foul. What is 3? Speak up. That's the equivalence point, where the moles of base is equivalent to the moles of acid. What is the approximate volume for the equivalence point? Should be about 25, because we wanted it to be 25 mils. So let's say I did an experiment and I have 25.68 milliliters for the equivalence point, okay? All right. Now, there was a note in your procedure how to get the equivalence point. Does anyone remember? There's a graphical way in Excel, or other plotting software to get to know the exact volume of the equivalence point. You guys remember? No. So there was another graph. And the x-axis was the same, milliliters of NaOH added. Delta pH. And how does it look like? It's supposed to look like small, but at equivalence point, there's supposed to be a peak. Why? Because at the equivalence point, tiny amounts of volume have huge changes in pH. Yeah? Okay, great. So if I want to know what is this exact volume, I make a second graph. Delta pH as a function of milliliters of NaOH added, and where it peaks. Some people have bad luck that they might have a double peak or triple peak, but where it peaks approximately, that's the equivalence point, and we'll discuss your data later in the lab. Okay, so I have the volume of equivalence point. How do I get the moles of the acid? Well, the moles of the acid is equal to the moles of NaOH. Why? Why are they equal at equivalence point? And what's special about the acid? 1 to 1 ratio. Right? It's a monoprotic acid. Okay. And that's pretty much the molarity of NaOH times the volume of NaOH. Now, if I have a titration with your base, you are supposed to have something around 0.08 or something like this in terms of molarity. And if I multiply the molarity that you guys got in the first lab of your base times the volume of titration, you get the moles. Guess what? I have the mass of the acid, the moles of the acid. I can use those two things and plug it into my equation for molar mass. Questions? Well, if I do, then my molar mass of my acid is just the mass of the acid divided by the moles of the acid. In this case, it's 46.86 grams per mole. So you got the molar mass of our acid. Any questions about this? Luis, any questions? Jonathan, makes sense?
Sort of.
You're clear that the mass of the acid you weighed out.
Yeah.
You understand that the molarity of the base times the volume of the base titrated to get to equivalence point. This you determine yourself. You put a label on the bottle. This is what you get from this graph here. These two things together gives you the moles of base at equivalence point. But at equivalence point, because it's a 1-to-1 ratio acid to base, it's equal to the moles of acid. By definition, mass of acid divided by moles of acid is the molar mass.
So that's the moles, sorry, the NaO, it's like the NaOH is the number of moles of the acid and the number of moles of base at equivalence.
Well, at equivalence point, that's the point of equivalence point, right?
Yeah.
They're equal according to the stoichiometric ratio, which in this case is 1-to-1. Right? That's the trick here. Okay. Any other questions? So this one should be straightforward calculation for you guys. You need to make this little Excel plot to get the volume at the equivalence point, and then just convert it to liters, multiply by the molarity that gives you the of the base gives you the moles, mass over moles, molar mass. Catchy, okay? You look like you're uncertain about something? No? No? Okay. Alright. That's one piece of the puzzle. The other piece of the puzzle is the pKa. Does anyone have an idea how to determine pKa?
Negative log. Well, wouldn't it be negative log would be Ka?
What is the Ka?
It would be,
On the recording.
okay.
We'll edit it out later, okay? We won't tell anyone that this one. No, never mind. So, yes, Teresa? Henderson-Hasselbalch equation. And what is special about the Henderson-Hasselbalch equation?
At equilibrium would be what's same as
pH equals to
pH.
Alexia, what do we call this region here? Buffer region. Where's the buffer the most optimal?
What do you mean, where? The graph?
Just in general, where's the buffer most optimal? When pH is equal to pKa, and that is true when the moles of A minus equals to the moles of HA. Now let's connect this here to the graph. Kevin, when is the moles of A minus equal the moles of HA in this graph, either one of them? No. Equivalence point is when the moles of NaOH is equal to the moles of acids.
Like the lowest
Do I need to draw squares?
Please do.
That's HA, okay? That is NaOH. Now, at equivalence point, how many NaOH do I need? 4. And if I have 4 NaOH, how many HAs are left? 0. How much A minus did I form at equivalence point? 4. My question is, how much NaOH do I need to add so HA and A minus are the same? What do you think, Eduardo? If I add 4 NaOH, there's no HA. 2. Ken, is that right? Okay. You guys want me to draw what happens for 2? Ken, help me out. If I have two NaOHs, how many HAs are used up? Speak up. 2. How many A minuses are formed? What's the ratio of A minus over HA? 1:1, it's the same, right? How much volume did I have to add to neutralize all of the HA? 25 milliliters, right? How much do I need where A minus and HA is the same? Half of 25. So this thing here is at half equivalence point. Now you have the hard task to look at your graph, look at this graph, and go to half equivalence point. Well, half equivalence point is 12.84 milliliters, and then you just go here and read off the pH. And that pH, let's say in this example, is 3.83. Melanie, based on the data provided here, what is the pKa of the acid?
3.83.
All right, piece of cake, right? Yeah. We just have to look at half the equivalence point, read off the pKa. Even Justin is happy about this. Good. So we have the molar mass, we have the pKa. Once you have that information and your unknown identity, I'm going to print out the list of acids and we can compare and see what you've done. Once you've done this, you've done your due for the lab today, and everything else you can do at home. But this is the minimum I need to see today.
When are the yellow pages due? Monday?
I need to look at the syllabus, but I think it's supposed to be either today or Monday. But worst case scenario, we turn it in all on Monday, and the formal report is after the exam, so you have a little bit of time there. All right. Question? Now, once you have this and the molar mass, you can identify, right? Because molar mass plus pKa, you can identify your acid from a lookup of a table. And then you can do things like calculate percent error. Typically, students have a very close pKa and a somewhat close molar mass. But in 1 out of like 5 students, the molar mass is sometimes dramatically different than what it should be. I'm not sure why that happens, but it sometimes happens. In any case, this is the minimum I need to see today. I give you guys a minute, then I'm going to erase it because now I'm going to show you the quick and dirty way to get a titration curve, and then I show you the proper way to get a titration. I just thought I forgot to press the record button, but I didn't. If I forgot, I would have been like, okay, let's repeat the whole lecture. All right. Now, what I need is an Excel graph with two plots. One plot is the raw data. That is the raw data, and you want to draw this as a scatter plot where you just draw the dots, no lines. And when I say raw data, I mean the raw data from the pH meter, right, that you recorded in your lab notebook. So that is one graph, and then the second graph is a constructed graph with Excel. Now, need one more color. Now, what is special about this graph? Well, depending on where you are, in the buffer region, blue, at equivalence point, green, or in region 4, where it's basic, I need like Excel data that you calculated. Well, how do you calculate this? So this is region 2, 3, 4. How do you calculate this data? Well, region 2, which equation can we use? There's a very specific equation that I want to use for region 2. What do we call region 2? Buffer region. If we call it the buffer region, then you can use pH is equal to pKa plus log moles of A minus divided by moles of HA. Now, this one in our example was 3.83. We determined this. How do I get the moles of A minus, and how do I get the moles of HA? Well, the moles of A minus is easy. That is equal to the molarity of NaOH times the volume of NaOH that you added. How do I do this in Excel? In Excel, I'm going to have two columns. One column is volume of NaOH, and the other one is pH. And in this volume of NaOH, you can just put data entry, 1 milliliter, 2, 3, 4, all the way to like 22 or something, right? You can use Excel and drag it down so you don't have to type in everything by hand. Yeah? And in the right field, you need an equation. And this equation is pKa plus log moles of A minus over moles of HA. How do I get the moles of A minus? That is the molarity of NaOH, so that's like about 0.08 molar, times this guy here, this guy here, 1 milliliter, 2 milliliter, 3 milliliter, 4, and so on. So you copy down the equation, and it will change the volume automatically in the equation. Question so far? Yeah.
For the volume would be the ones we got from the data, the 50 volumes.
The volume, no. The volume is any number between 0 and equivalence point.
So you can put
If you want, you can put 1.00, 1.01, 1.02, 1.03, all the way up to 25 milliliters. And you can have 100,000 entries if you want with Excel. It's up to you. You just drag down the formula and you just drag down the numbers. So this just means we're calculating for a hypothetical volume added how the curve should look like. And you will notice here, where pH is equal to pKa, that curve looks really good. Here, the points will be very close to the curve. But here, the points will deviate a lot when you go away from the pKa, from the volume where you have the pKa, half equivalent. Yes?
Do you have to start from 0 milliliters?
You don't want to start from 0, because at 0, you know you have to do an ice table to calculate the initial concentration. So you want to start at 0.1 milliliters, but not at 0. I just put 1, 2, 3, 4 just for simplicity. That's 25 points, that's decent. But it's in a computer. As many points as you like. Yeah?
So, in the pH quality equation, would it have to have an equation instead of this equation?
So I'm not done with the equation, I just put the modes of Na, right?
Yeah.
So if this would be A, and this would be B, and this would be 1, 2, 3, then this would be 0.08, whatever the number is, times A1. Right? How do I get the modes of HA? Remember how I draw the squares and how you realize the more HA I use up, the more A minus I form? Yes? So this one will be the modes of HA initial minus the molarity of NaOH times the volume of NaOH. Yes? So it's basically the modes of initial HA, but they're getting reduced by how much strong base I add, because that base is used up, using up the HA forming A minus. So in Excel, this would be a number minus 0.08 times A1. How do I get the initial moles of HA? Yeah. How do I get the initial moles of HA? No ice table. There's two ways. You know the mass of X and the molar mass of X, you can get the moles of X. Or you know the molarity of the base at equivalence point, which is equal to the moles of X. Ideally, they're the same number. In an experiment, they might not be, but ideally, they're the same number. That gives you the initial modes, but in either case, it's a number that you can calculate. All right, so we got the buffer region using Excel. remembers the equation for region 3? All right. This guy here is this guy here. What is the volume of base in my example? That was like 25.86, right? The volume to equivalence point. What's the volume of the acid? Remember I told you guys to weigh out with a graduated cylinder how much water you put in. I said it doesn't matter if it's 150 or 250 milliliters or 50. Just weigh out with your graduate cylinder how much water you dissolved your sample of acid. So you need to go to your yellow pages and you need to look how much DI water did you add to your sample X. Yes? And then pH is basically 14 minus log of OH minus concentration. So this number you can manually enter at 25.86 milliliters, and then whatever that number is. So this is region 3, this is region 2 in my Excel table.
So for the first equation, we would just drag it to the right and forth, like,
Yes. Hey, who memorized the equation for region 4?
It's the moles of OH excess, excess over the volume of acid plus volume base.
Okay. Let's say this is A50, okay? And A50 is 26 milliliters. Volume of base added is A50. Volume of acid added, that's the number you weighed out in your yellow pages initially, like 50 milliliters or whatever that is. This number here is a given number. We calculated this earlier. And how about the moles of NaOH? That's the molarity of NaOH times the volume of NaOH. And this would be A50, and this would be 0.08 molar. And then you do the same business and copy paste this equation all the way down. Of course, you need pH is equal to 14 minus log OH minus excess, right? And then you copy paste this equation all the way down to 50 or 40 milliliters or whatever your last volume is that you recorded your data points for. Once you do this, all you need to do is sketch the two plots in Excel. scatter data and this table. So two graphs in one, and this one can be a scatter plot with lines, or just lines, sorry, just a line plot. And that will create this line and then the dots representing the data, and you can see how close the line is to your data. Question?
Yeah, what do you mean by 850? Is that like the last
It's
column
just,
recorded?
no, I'm just saying like, if this is A1, A2, A3, and so on, maybe this A50, A51, A52, A53, and so on. It's just a label in Excel. All right. Any questions about the quick and dirty?